So learning outcome 19, right, is just what do we mean by the term atom and nucleus? So we talked about this yesterday. So an atom is the smallest unit of a material. Which retains the same chemical properties. So basically, if you were breaking things down and down and down, splitting, right, a material into something smaller and smaller and smaller, the smallest thing which still acts the same way chemically is an atom. Now, our model of an atom, now can I stress this is just a model, it gives us a useful idea of the basic parts, right? But it's not what an atom actually looks like. An atom doesn't really look like anything, they're too small to see. Right? So an atom model Okay, so this is the kind of traditional model of an atom that's often drawn. All right, and we're going to identify the various parts. So the small bits whizzing around the outside are called electrons. Okay, and this central bit, where the heavier particles are, is called the nucleus, which is made up of protons and neutrons. The other part that we mentioned briefly yesterday, an element is a material made up of only one type of atom. So most materials will be a mixture, right? But if they're pure, if there's only one type of atom, then that's what we call an element. So we'll group together 21 and 22, which are all about what's called nuclear notation. So nuclear notation is the idea that we have a specific element and we use two numbers to describe that element. So this is called nuclear notation. Right? Now, you'll find it done in slightly different ways. When we do it in this course, right, and in some textbooks you find the mass, the M is at the top, the A is at the bottom. Other places you might find it written the other way around, but I'll give you a clue about how you know which one's which. Okay? But to define that then, we need to define what these things stand for. So X is the chemical symbol. Now you don't need to memorize them. But e.g., H stands for hydrogen, C stands for carbon. Okay, I'll show you in your booklet in a wee second what's called the periodic table, which just lists all the elements with the... Yeah, okay. A is the atomic number. And let's say we'll write it in the bottom, sometimes see it written in the top. The atomic number is always smaller than the mass number, right? Or at the very worst, equal to. Right? So it's smaller than or equal to the mass number. The atomic number, right, that's what it's called, right? But it tells you the number of protons in that atom. Okay? And that is what defines each element. I'll get to M in a wee second, yeah. So in some ways we could actually do without the chemical symbol, because if you know the atomic number, that tells you which element it is. Right? All carbon atoms will have a 6 as their atomic number. Right? All helium atoms have a 2 as their atomic number. Because what makes them carbon is the fact that they've got 6 protons. What makes it helium is the fact that it's got 2 protons. Right? That's what we mean by carbon, that's what we mean by helium, and so on. Okay, so this is what defines each element, e.g. 2 for helium, 6 for carbon. And one more wee bit about atomic number. In a normal atom we discussed yesterday, that will also be the same number of electrons. But it's quite easy to change the number of electrons, as you saw in junior school, that you can rub something that can change how many electrons are in it. So usually, this will also be the number of electrons. M is a mass number, and it tells you the combined, right, and that's important because people tend to forget that, the combined number of protons and neutrons, basically the number of heavy particles in the element. Okay, so for example, in fact, no, I'll do examples separately in a wee second, okay? Right, but remember I said the A defines the element, right? The atomic number tells you which element it is. You can get more than one type of the same element, right? What are called isotopes, which means they have different mass numbers. They've got the same number of protons, but different number of neutrons. And that makes them what are called isotopes. Yeah, Nicholas. So isotopes are the same element but with different mass numbers. And that's because they have more or less neutrons. Right, we'll look at a couple of examples of that. A couple of examples. Okay, so if I wrote up 6, 12 and C, that's what we call carbon, but carbon 12 to be more precise. Now, what can I tell from this? Well, I can see that the atomic number is 6. That means carbon 12 consists of 6 protons. Normally, that would be the same number of electrons, so we'll have 6 electrons. And how do we know it's 6 neutrons? Right. So to work out the number of neutrons, you have to do 12 take away 6. Sorry. Okay. And as we mentioned yesterday, for the lighter elements, you do quite often find that you have the same number of protons and neutrons. But this is also carbon. Why do I know that that's also carbon? 2 reasons. 1, Richard? It says 6 for both of them, and the chemical symbol's the same for both of them as well. But this is what's called an isotope of carbon. So because the 6 there, it's still got 6 protons. Right, unless you've charged it, it would have 6 electrons. But now to get the number of neutrons, we do 14 take away 6. So it has 8 neutrons.